Hello, Honors Algebra 2 Trick students. Today's video is our second video on the angles in the unit circle. Uh, we've done evaluation of trig ratios like this in the last video. We can think about where this angle is located. It's in the fourth quadrant and it has a reference angle of pi thirds, which means the opposite side is largest at square root of 3. 1, 2, and since this side is going down here for the opposite, it's going to be a negative square root of 3. But the cosine's the adjacent over the hypotenuse, so it's the positive 1 over the positive 2. It's 1/2. Now, the tangent of negative 11 pi sixth, we're going to be going clockwise because it's a negative angle. 11 pi sixths will bring it into the first quadrant. So it gives us a pi sixth reference angle, which gives us 1 square root of 3, 2. So the tangent is the opposite over the adjacent, which gives us 1 over the square root of 3, or square root of 3 over 3. Now, those trig values that we've been doing, those are extremely important that we're comfortable and able to find. And eventually it'll keep being quicker and quicker for you all. But we have finding the cotangent of angle A here in problem 3. And it tells us the cosine of A is negative 2/3, which does not tell us what that angle is. It is not one of our special triangles. But we do know A is in quadrant 3. So since angle A terminates in quadrant 3, we know it's over here, and cosine is the adjacent compared to the hypotenuse. Well, cotangent is the adjacent compared to the opposite, that ratio. Now, only if we knew the opposite side's length compared to the other sides, well, since cosine is the adjacent compared to the hypotenuse, it's negative 2 over 3. And since we're in quadrant 3, it makes sense that this adjacent side is negative because we're going to the left on the x-axis, which is in the negative direction. Well, it'd be really nice to know this opposite side. Well, these are right triangles. In a right triangle, when you know 2 of the 3 sides, you can do Pythagorean theorem. So negative 2 squared plus whatever that is squared is 3 squared. So x is either the positive or negative square root of 5. Well, it's going to be the negative square root of 5 because we're in the fourth quadrant and this segment is going downwards. So the adjacent over the opposite is what we find for cotangent of A. The adjacent is negative 2 over negative square root of 5. The negative symbols are going to cancel out. And then we want to rationalize the denominator, so we'll multiply by square root of 5 over square root of 5 to give us positive 2 square root of 5 over 5. Now, what would happen if an angle wasn't a reference angle that we typically use, a pi 6, pi fourths, pi thirds? Well, we just did one a second ago, but we also have these issues of quadrantal angles, and they're angles that terminate on one of the axes. Those happen when the angle is on the x-axis or the angle is on the y-axis. The problem with this angle here at 0 or at 2 pi or at 4 pi is that it doesn't actually make a reference triangle. So what we can do, though, is if I was to draw this triangle isn't real. The problem with this triangle is it actually has a height of 0, and this ratio of adjacent to hypotenuse, it's actually the same segment. It's a 1-to-1 ratio. And if we were over here in the pi direction, it also has no height to it. And it's adjacent to its hypotenuse as a ratio of 1-to-1, but it's going to be a negative adjacent side. Well, if you were to go at pi halves, you would you'd be right here. But the problem with that is that's also not really a triangle. It's a segment collapsed onto itself. So if you looked at those angles that are pi halves, they were headed towards, they were triangles like this right before. And then right at the very end, this came over and it collapsed on that axis. This length's actually 0. And this opposite compared to the hypotenuse are the same length because they are the same segment. Then, if you were to consider down in 3 pi halves or negative pi halves, it's very similar except for the opposite side is a negative because it's going downward. So it's a ratio of negative 1 to 1. We're going to find all of the trig ratios for theta is 3 pi halves. Now, 3 pi halves is down here. It'd be this segment by itself. However, when I draw it, I don't draw it like that. I draw it like a reference triangle, like it would be a piece of that TIE fighter or that bow tie where it's being drawn perpendicular to the x-axis. But I know that this side is actually 0, and this side's actually a ratio of negative 1 to 1. So we want all 6 of the ratios. The sine of 3 pi halves is the opposite over the hypotenuse, which is negative 1 over 1, which is negative 1. The cosine of 3 pi halves would be considering our adjacent side. Well, our adjacent side is 0. 0 over the hypotenuse of 1 gives us 0. Tangent of 3 pi halves is our opposite divided by our adjacent. Our opposite is negative 1 divided by our adjacent is 0. Well, this is an issue. We can't divide by 0. So this ratio does not exist. It's an undefined ratio at that value. Well, we still have 3 other ratios we need to check. We can check cosecant, the reciprocal of sine. Well, the reciprocal of negative 1 is negative 1. Secant is the reciprocal of cosine with the exact same angle, is now 1 over 0, which does not exist. It's an undefined angle. And then cotangent of 3 pi halves is not 1 over does not exist. You can go look back at this ratio. You can reciprocate that. That gives you the adjacent over the opposite. The adjacent was 0 over the opposite of negative 1. This is 0. We got 2 more for today. We have a sine of 11 pi. Well, got to think about where that's at. 11 pi is 11 semicircles. 2, 4, 6 semicircles, 8 semicircles. I don't need to do all this writing. I know that all the odd ones are over here, and all the all the even quantities of pi are over here. All the odd quantities of pi are over there. So we know we're on this side, on this left side is where we're ending. Well, sine is opposite of our hypotenuse. That opposite side is a ratio of 0 to 1. It's 0. Now with the cotangent of 450, we have to realize where this is at. This is in degrees. 360. This is 360 plus 90, which makes this angle up at the axis. So really this is 0 as it goes 1 to 1. Cotangent is the adjacent over the opposite. The adjacent is 0. The opposite is 1. So it's 0 over 1, which is a cotangent of 0.